This video is for those of you that have chosen to do an experimental design for your research. So basically, you have not chosen to do a survey or an interview where you're just going to sit down and ask people questions to gather information. You have chosen to actually implement some type of treatment. So what makes your design a little different is the fact that you really cannot get a random sample for this, because if we are going to force people to do things, we can't really just take a random selection of people and then say, hey, you, this random guy I've just pulled off the street, I'm going to make you do this. That doesn't happen. So when we are actually implementing treatments, usually what we have is we either have a voluntary response sample, because these are people who have actually volunteered to take a part in our study. You'll see this a lot in medical studies if they're testing drugs or medication. These are people that actually have to volunteer and sign and agree to do the treatments that you're implementing. Or if you are studying an object or a thing instead of an actual person, then you probably have a convenience sample. Because you've just taken what's easy and what you already have, okay? So for example, let's say I want to test 2 different laundry detergents to see if they make a difference in how they clean clothes. So I'm going to go to the laundromat because they've got a lot of washing machines in the laundromat, and I can do them all at one time, and I can just get my study done. I'll have multiple sample or multiple test objects there. Okay, so what I'm going to start off with is I'm going to start off with, let's say, 40 washing machines. Okay, and these 40 washing machines are going to contain clothes in them that are stained, and we're going to assume that all of those clothes, we have tried to get the same stain on them, and we're going to test this out. Okay, so the very first thing that I have to do is I have to kind of look at what are some confounding variables that may affect my study, and if I can control for those, then we can make this a better study. Okay, so it may be the difference in the machines. That could be cleaning the clothes better more so than another. It may not necessarily be the laundry detergent. It could be the temperature of the water that we're washing the clothes in that could make a difference. It could be the type of stain that's on the clothes. It could be the different types of fabric that the clothes are made of, and I'm sure there are a lot more that we could come up with, but this is just kind of a starting list. So you would really want to take time here and try to think of every single possible thing that may affect this stain that we need to try to control for. Okay, so I can control the temperature of the water. I'm going to make sure that everything I do is washed in a cold cycle. I can try to control as much as possible the type of stain, so I can try to make sure that that stain is the same, whether it's dirt or ink or whatever you're testing. I can make sure all those are the same. I can try to administer the same amount of stain on each article of clothing. Different fabrics may affect this, so I can make sure that they all have the same fabric, they're all the same type of shirt or whatever you're testing this on. Now, as far as the difference in the machines, that's not really something that I can control, because I'm using a laundromat, and when I walk in, on one side of the wall they have some older machines that have a different type of brand, and they have some newer machines that have a different type of brand. And that may also affect this as well. So because that's not something that I can make the same, then when I start this design, I'm going to want to separate these machines into 2 groups. So we're going to have a group of older machines, and we're going to have a group of newer machines. And what you'll see is there is no randomization to this. These were already in the laundromat when I started. So this is what's called blocking, because I couldn't make these the same, and I do think they're going to affect the outcome of my experiment. I'm just going to separate them out. So I have 20 older machines that are going to be a part of the study, and I also have 20 newer machines that are going to be a part of the study. That way we can really look at each group separately, and that would help assure me that it is the laundry detergent making the difference and not the machine. Okay. All right, so once we have controlled for everything that could possibly affect the results of my study, we have to recognize that there are some confounding variables out there that we may not even know exist. So if I don't even know they exist, then there's no way that I can try to control for it. So what we have to do to take care of all those things we don't know about is we have to make sure that we randomize our experiment. I didn't mean to put two eyes in there, but you got it. All right, so randomizing the experiment, once we have blocked and controlled for everything we think is going to have an effect, now whatever our factors are going to be, which is your explanatory variables, what is it that you're putting into the experiment that you think is going to make a difference? And this is going to be your laundry detergent. So we are testing two laundry detergents. We'll just call one of them Tide and one of them, I don't even know what laundry detergents are out there, but we'll just call them laundry detergent number 1 and 2. So what I want to do then is from the old machine, I want to branch out. And we're going to give the old machine the laundry detergent number 1. And we're going to give the old machine's laundry detergent number 2. Okay. But when we do this, we need to make sure that we randomize how we do this. So because I have 20 old machines, and we want to make sure that we get 10 in each one of these groups so that we have an equal number in each group. You can use your calculator to do this. If you go to math and then go over to probability with your right arrow, probability or RandInt, you should have one that is a no repeat. I think it might be number 8. And when you use that one, it won't repeat your number, so we won't use the same machine twice. So if you do RandInt and say, okay, I'm going from a lower of 1 to an upper of 20, I have 20 total old machines, but I only want to choose 10 to go in this first group. If your calculator spits out numbers of 4, 3, 1, da 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 da, up to 19, then whatever numbers those spit out, those are going to be the machines that you use in group 1. Now, naturally, you're going to want to number these machines before you do that, because you'll have to have a number assigned to the machine before you'll know what those numbers actually mean. Okay, so once you pick the 10 that are going in group 1, the other 10 will go in group 2, and you have randomly assigned these. So these were called your factors. They are also called explanatory variables. These are what you're putting into the study in order to see if it's going to make a difference, okay? Now we obviously have to do the same thing in the 20 new machines. So we are randomly going to select which 10 are going to go into a machine with laundry detergent number 1, and which 10 are going to go into the machine with laundry detergent number 2. And again, we'll want 10 in this group and 10 in this group. Okay, so these are called treatments. The laundry detergent are called the treatments, and those treatments are what have to be randomized in order for this to work. Okay. So once you have placed your explanatory variable in there, and your study may have more than one explanatory variable. If you were testing, if you wanted to test the laundry detergent as well as the water temperature, then you could break off of this again and do cold versus hot off of all 4 of these boxes. And then your treatments would be like the old machine with laundry detergent number 1 in cold water, or the old machine with laundry detergent number 1 in hot water. So you could branch this off as many times as you needed to, depending on what factors or what explanatory variables you're wanting to test. Now, once you have instituted all of these explanatory variables or what you're testing, in the end, you actually run your experiment. So once I pull the clothes out of the machine, we want to bring this all back together where we have some way to compare in the end how well that cleans. So maybe we want to look at the percent of the stain that is now gone from where it was in the beginning. So some mathematical computation that would help you compare those 2 groups. Okay. There are some studies where you do not have a comparison. So like if you had just gone into this study saying, well, I'm just gonna run some machines with this new laundry detergent and see if it makes a difference. You can't just do it with one laundry detergent. You have to have it something to compare it to. So like if you were doing a study, even though it's not morally sound for you guys to be doing a study with medication, but I wanted to see if a new medication was actually making a difference in patients. I can't just give them that medication, give all of them that medication, and then see if they get better. You have to have a group to control. So a control group in that situation would be just giving another group a sugar pill and just make them think they're getting the same medicine, and then compare those 2 groups to see if the real pill was actually making a difference. So make sure you do have some type of comparison in there, or some type of control group. Okay, so there are 3 things that you need to double check after you've done your design to make sure that it is a good design. First, that you have controlled for all confounding variables. And then once you've done that, you have randomized which subjects or which experimental units that you started with are going to get your treatments. And then the third thing you need to make sure is that you have included replication. And in order to include replication, you just have to make sure that you have multiple objects in each treatment group. And as long as you have more than one there, then you have replication.